We're now going to talk about the radical sign. And the radical sign looks like this. And you may look at this one and already know what it is. This in particular is a square root, but it's also, the sign as itself is a radical sign. And a radical sign is trying to undo a power. So a square root undoes a square, a cube root undoes a cube, a fourth root undoes a fourth power, and so on. So our actual generic symbol is an N inside this little valley area and the symbol. And this is really important because the way this works is, suppose we have the square root of a equals b. Well, this means that b squared equals a, and it means that b is greater than or equal to 0. So both of these conditions have to be true in order for this to be true, that the square root of a equals b. So let's get a couple of other definitions while we're looking at this. Nth root of a, and that's how we say it. We say this is the nth root of something. And we've got some definitions to learn. So this is the radical sign. It's that funny little checkbox. It has a root n. That's why we call it the nth root. It has a radicand, which is the number underneath the radical sign. And it's important to recognize that this always returns what we call the principal root, which is what this over here is trying to say. So, as we're looking through these radicals, you want to be very, very, very careful about this. So we're going to demonstrate this with square roots in particular. So we're going to start with the statement, the square root of a equals b. And we're going to have two tests. We're going to have test 1, which says that b squared equals a. And we're going to have test 2, which says that b is greater than or equal to 0. And then we're going to say, we'll have some conclusion about that. So it's true if 1 and 2 pass. So let's look at some examples. Let's start with the square root of 4 equals 2. Well, 2 squared equals 4, that's true, so that checks out. 2 is greater than or equal to 0, so that checks out, which means that this is a true statement. Well, we have another root of 4. Let's see what happens with the square root of 4 equals negative 2. Well, here we get negative 2 squared equals 4, which is true. A negative times a negative is a positive. But when we check to see if negative 2 is greater than or equal to 0, that's false. That's not true. And so this is not a proper principal root. So this guy doesn't work. Alright? What about the square root of 1/9 equals 1/3? Does 1/3 squared equal 1/9? Sure enough, that one checks out. And is 1/3 greater than or equal to 0? Sure is. So this is a true statement. Okay, what about the square root of 7 squared equals 7? So does 7 squared equal 7 squared? That 7 squared is that one. It sure does. Is this 7 greater than or equal to 0? It sure is. That means this is a true statement. The square root of 7 squared is 7. The final thing that we're going to look at, let's suppose that we have the square root of minus 7 squared equals minus 7. So is minus 7 squared equal to minus 7 squared? It better be. We wrote the same thing on both sides, just like the earlier example. But notice that negative 7 is not greater than or equal to 0, so we failed this test, which means this is false. So even though I took the square root of a negative 7 squared, it didn't give me a negative 7. It actually gives me the positive 7. This is what we mean by the principal root. Because the square root of minus 7 squared equals 7. This still comes out true because they both are positive 49. And 7 is greater than or equal to 0, which is true. So this is true, and the square root of negative 7 squared will return a 7. So you want to be very, very, very careful when you're using these radicals that you return the principal square root, which for square roots and for all even roots is the positive one.